whenever you do a chi-square test of difference, you should probably always follow it up with a test of correlation. And on that form that I distributed to you, there are various tests, but the one I think I mentioned there was Yule's Q. Yule's Q is a simple formula that is AD. So if we label these cells A, B, C, D, or if this was, we're labeling these cells, just label across the gulf, this would be A, B, C, D, E, L. But Yule's Q is only going to work on a 2x2 table though, so it wouldn't work here. So if we wanted to talk about the extent to which there is a relationship between delinquency and weekend studying, we could take it by taking a ratio of A times D, cell, the frequency is an A times D, minus B times C, to A times B plus B times C. So, pretty simple, I mean, but it will give you a greater understanding of the data in terms of the extent of the relationship between the two variables you're interested in, rather than, as chi-square does, just simply whether or not there's a difference between two groups on the independent variable and that dependent variable. So, taking this particular data, A is 75, D is 60, that would be 75 times 60, minus BC, so it's AB minus BC, that would be 40 times 25, minus 40 times 25. And then do that same thing in the denominator, 75 times 60, but now it's plus 40 times 25. You do that for this data, you get 3,500 over 5,500, which is 0.64. Now, so we have a number that we can meaningfully interpret here in terms of a correlation, having a value that's going to vary from 0 and a positive one in this case, or 0 and a negative 1. And so when we think about how important that is that it's a significant relationship, we can go back to the criteria that we talked about when we talked about correlation in terms of substantive significance. How important is that relationship? And remember, that's what correlation is able to tell us beyond statistical significance. And we'll use the statistical significance in chi-square. There is a relationship, a statistically significant relationship between delinquency, whether or not you're a delinquent or not, and whether or not you study on the weekend or not. So we've established that already. Substantive significance says that that relationship is a high one, if you remember our criteria, because the coefficient, Yule's Q, is a 0.64. A 0.64 on our diagram is falling between a 0.61 and a 0.80, which we've said when we talk about Pearson's R is a high relationship. So there is a high tendency in this data that when I look at the numbers for delinquents, if I want to concentrate on delinquents, for delinquents to study on the weekend. Now that's contrary to intuition, obviously, but the way you're making the interpretation is direction has to do going up on one variable, or you're going up on the other variable. So going down on one variable, or you're going down on the other variable. So going from 2 to 1, that's going down, because I want to emphasize delinquency. So going from 2 to 1, going down, this is a positive relationship. What does it mean when I say going down on this variable, 2 to 1? It's studying on the weekend. So there is a high tendency for delinquents to be studying on the weekend. Okay? That includes direction now. So remember, correlation tells you statistical significance, substantive significance, direction, and as a PRE. Now the PRE is not meaningful here for Yule's Q. It does not make sense to square Q and have it meaning. It does for R, but not for Q. So we can get 3 of those 4 ways that we can interpret a correlation out of this Yule's Q. Statistical significance, we used the chi-square instead. It was statistically significant because the observed chi-square was, from yesterday's point, 25.06, was in the rejection region, which started with values of 3.84 or higher. Substantive significance is a high relationship and direction. Delinquents tend to be studying on the weekend. So, and that's about all I want to say here with regard to this particular problem in terms of a test of difference when the measurement on that dependent variable is discrete. Now, this only works, Q only works for a 2x2 table. If you have a table like what you have, like the practice problem that I asked you to do, prove to yourself, this is, I think, the hypothesis that you were done with was that there's no difference between skin color and perceived skin color discrimination. That is, that there's no difference between light, medium, and dark skin, and whether or not you perceive skin color discrimination or not, yes or no. That's Yule's Q is not going to work there because that's a 2x3. So we need something like Cramer's V. Cramer's V. You can make use of Cramer's V because we've already calculated chi-square, so it's not a big jump to be able to have a coefficient that would fit the data that you have in this 2x3. You just take chi-square, in this case it's the 0.97, divided by n. And your n is 12, 20, 17, is 42. So, and of course, that's going to be very unimportant. The 43?
69, 18, plus 18.
So that, again, is going to be very near zero. The correlation between those two variables is going to reflect the fact that you should have concluded that there was no difference. So this chi-square is not statistically significant. That coefficient that you get, the 0.00, when you make that division, 25.06 divided by 43, which is equal to, you got a calculator? It should be a 0.00. Zero point five. $43 is the n. Yeah, on this data here. All right. I think it's going to be near 0, but 0.58. But don't worry about it. We're not going to do a Cramer's V. My point is that there are other statistics out there that if you cannot do the Yule's Q, that's available to you. Okay.
So we don't have to.
All right. That's all I'm going to try to do, class. Rather than trying to move into the Spearman's role and Christopher Wallace. That was 210. test on one of the tables. That was a logical speaking. So we're going to follow the one that was practical speaking, where you have tests that will allow you chi-square. If you have ordinal data that is discrete, then use chi-square. If you have ordinal data that is continuous, then just use Pearson's R on the t-test. All right. Any questions on chi-square? All right. Let me distribute this study guide. So on Wednesday, we will be talking about anything from what comes out. And then at 4 o'clock, the seniors will move on and the seniors take the exam.
So you're gonna be done at 5?
Oh,
I was thinking second grade.
Okay, class, so we'll pick up again on Wednesday.
Well,